right, everybody. Welcome back. Hope everybody had a chance to grab their favorite beverage. We've got David Burkett here from Corvid Cyberdefense. He's a longtime ColaSEC member. You may have seen him from previous presentations. Um, been always good content. He's one of these guys that has worked his way up. Obviously, spent a lot of effort and time to go above and beyond the typical, hey, I go and worked for the state for a little while. I may be uh, referring to myself a little bit, and he has, really skyrocketed and taken cybersecurity into a passion and really, really gone above and beyond.
Do
So
we need to go back 3 slides, David?
What? No.
Girl's just being a little bit hard on himself. I want to make sure he's getting help if he needs it.
Oh, no. I did hear that part. I love that part. I'm just giving myself grief. We're all good here. I love what I do. I love what David Burkett does. I love what all of you do. And I'm really excited about this presentation because I do have a bit of a interest here, self-interest. I think that the program I'm working on at work, this will be very directly related. So I think I'm going to learn a lot. So I hope all of you do too. I'm going to hand it over to David, and hope y'all enjoy it.
I love LAMP.
So this is actually a talk I've wanted to do for a few months now. I've just been very, very busy. But essentially, again, my name is David. I'm the SOC manager at Corvid Cyberdefense. Just as some background, I've been a SOAR architect for Palo Alto Networks. If you're not familiar with the terminology SOAR, it stands for Security Orchestration, Automation, and Response. While there, I was on the customer success team and helped essentially automate and develop playbooks for pretty much exclusively a few dozen Fortune 500 companies and large federal agencies, which gave me some really awesome insight. And I was just in a really cool position getting to touch and work, touch a lot of different technologies and work with a lot of different teams and really get to know a lot of these teams and learn about some of their processes and how they do things. It's been super helpful. And I've also been in the position where I've had to build a SOC from scratch now, or a security monitoring program. I think 2 times, and I'm now actually managing my third SOC. And I know just from experience, whenever I look for, how to build the right SOC or whatever it might be, it's always really high level strategy, which is helpful to some degree. But on some level, with how complex and how new security is, you do need some operational examples of how to actually implement some of these programs properly. And one of the things that I kind of came across was that a lot of the, I should say, newer security monitoring programs compared to some of these large, like Fortune 500 companies and federal government agencies that have just tons of budget and have been doing security, for a lot longer period of time. A lot of the newer programs are really focused on, like, what tools do I need to buy? What's the best EDR solution? That kind of thing. And that just combined with blue teams historically being kind of secretive and closed off to the type of information sharing that they do. And then lastly, the biggest piece is I really wanted to reinforce the idea that with just free and open source tools, you can run circles around people that have spent, I would say even over a few $1 million on, SIMs and EDR tools and stuff like that. All of those are just tools. They don't actually, they're not going to be what determines or what makes your security program that next level. So I have a few goals for this talk. One, I definitely want it to be interactive because this is such a topic that's hard to find information on. I'd like to share and kind of help wherever I can. So if there's any feedback, feel free to please speak up and ask questions. If someone could also just keep an eye on the chat for me. But also to share just some of my lessons learned. Like I mentioned, I've built 2 SOCs. I'm now a SOC manager for a managed service provider. And I along the way, I've come across a lot of resources and just things that have kind of helped me. One other kind of thing to note is I'm going to have an example of something come up. And while I was having a colleague of mine actually review my talk, he thought I was talking about his security operations center, but it's a very common problem. So if it describes you, know that this SOC is not about any company in the Carolinas. So you can sleep better at night.
Or is it?
No, it's definitely not. And it's going to be, honestly, it's vague.
About
Like I
Virginia
said, it's something that's essentially a super common problem. Hence, part of the reason that I wanted to do this talk. So, first, let's get to defining things. So, security operations center as a term means a lot of different things to a lot of different people, and that causes a lot of confusion. So, while cybersecurity as a career path or whatever has been technically around for, a number of years now, it's I would say maybe the past 5-6 years, it's really kind of exploded into something else, and the amount of people that are getting into it or switching over to it as a main focus is just a totally different ball game. And with that, there's a lot of people that have done senior, like high-level IT architecture and that kind of thing. That are super smart people, but again, they've just not had the opportunity to be exposed to security operations center. And so that can lead to some kind of conflicting ideas of what a SOC is actually supposed to do, and actually because of that very reason, a lot of organizations are actually getting rid of the term SOC completely. If you look at CrowdStrike, they call their team the Overwatch team. FireEye's Managed Defense. Red Canary refers to theirs as a CERT, and a lot of that is just because of the ambiguity of SOC. Microsoft, I think, has one that I actually really like, and they call it their detection and response team. So something that's just kind of coming down the pipeline, or just something to keep in mind, that can be a kind of a way to kind of social engineer people if you're just getting your security monitoring program off the ground, rather than calling it a SOC, maybe giving it a more clear name of what the actual purpose of that program is. But overall, what I'm going to do, this talk is about security monitoring programs with essentially the mission to detect and respond to threats, but I'm probably going to say SOC for short, and just because that's realistically the most common nomenclature. And one last thing before I forget, at the end of the talk, if I haven't spent a few hours just digging into various different things, we'll go ahead and stop recording, and I'll show you guys a really awesome life hack to basically automate pretty much any kind of security tool you could want, super easy, or basically how to find code to do the automations that you need. Something that I found is very useful as a skill set and a thing of knowledge to have. But so with that, I'm going to dig into it. So I actually broke this out into 3 things. The first one is going to be on mission statements, which I know sound boring, but it's the thing that I've found is one of the most important parts of a security monitoring program. And again, this goes back to what I was saying before about people just not understanding the overall purpose of a SOC. And I'll give you guys an actual real world scenario that I've been in before, and I've actually seen at quite a number of companies and organizations. So it's not unique. So this can be something vague, but the idea is when you're building a security monitoring program, or if you're calling it a SOC, something to that degree, you should get a mission statement. It can be just a high level strategic statement saying, the purpose of the SOC is to do something, or to perform continuous security monitoring 365 by 24/7, whatever it might be, through whatever collection tools or whatever you want to kind of put in that front. But at the end of the day, make sure you declare what your security monitoring program is, and you have a mission for it. It's going to be really important for SOCs. And let's actually just dig into the real world example. So I call this Ops Gone Wild. So I actually did some private consulting for a company. I guess it's been about I've lost all track of time because of COVID, probably roughly a year ago now. And while in there, I was helping them essentially get their SOC off the ground and get up and started. So they had a problem. They had a SOC. Their management team just didn't feel confident in their capabilities and their detection capabilities. So I was asked to kind of come in and give some advice, see where they could improve, that kind of thing. Did a bunch of interviews, kind of solved their processes. And long story short, what I came to find out was they had a really competent operations team that really knew what they were doing. And those of you that have worked for state government especially will know that unfortunately sometimes internal politics can come into decision making in terms of who is responsible for what.
No, that never happens.
Right, and because some internal politics, and because the ops team was again very competent, they were able to push off the internal firewall support ticket workload to the SOC. Essentially, the reasoning and the logic being, they're the security operations team. Why aren't they managing the firewalls? That's a security appliance. Realistically, my personal opinion was it just didn't seem like they wanted to handle the workload just to do the basic, open up this port or figure out why something is offline kind of troubleshooting that just comes with day-to-day firewall management. And the reason that that's important is because that actually ended up becoming the primary responsibility of the SOC employees. And that actually becomes a problem for a few reasons. One, SOC analyst skill sets and engineering skill sets are overlapping, but they're different. And what I mean by that is, well, a sysadmin or an engineer is going to have great ability to configure, set something up. They're typically going to lack some level of kind of contextual awareness of why something might be bad or what to look for. And that's nothing on them. It's just not their job role. The flip side of that is they make great security analysts because they also have the context of what looks normal from an admin perspective. But at the end of the day, they are separate job roles. One's investigative and one is engineering. So it's two kind of different skill sets and mindsets. It's something.
Question.
Yep, go ahead.
Did you just say NADMIN, like network admin?
No.
Oh, okay. Never mind.
Might have stumbled across my words, but
That was a good find, though. That's awesome. Did you just invent a word accidentally?
Sure, I'll take it. But so, anyways,
let's
tweet that out.
I'm gonna veto that existing. No.
No. Come on,
Change
Adam.
it with a G.
Live
It's gotta be
tweet
with a
this.
G. That's a bad idea. Never mind. Don't name it. Don't do it with a G. Never mind.
Making it worse, Corey.
Anyways,
Yep.
back on topic. So what this really led to is anyone that's managed a firewall or has had to deal with firewall support kind of trouble tickets you're realistically, those are going to come in kind of constantly and throughout the day, depending on the size of your organization. As a SOC analyst, if I'm investigating something and I have to stop what I'm doing, take a phone call, troubleshoot some firewall type thing, and now I've lost all of my context. I've had to do some context switching. That's a big problem, especially if you're in the middle of handling an actual incident. Now, again, I know that especially when you're getting started, there's a lot of overlap between some of these engineering teams and some of these quote unquote analysis teams. But at the end of the day, it's important to realize long term, at least, they are different skill sets, and you should be aware of that. So again, basically, their job really just became managing the firewall and then responding to just alerts as they were able to in the background. That's just not an effective way to run a security monitoring program. So with this, so let's talk about why that happened. One, again, there's a lack of understanding of what a SOC actually did, and that they, like I said, they had a great ops team. They were really smart. They actually implemented things that were, redundant, had great uptimes, just well implemented and configured, but they just didn't understand the purpose of why the SOC was created to begin with, and the executive teams making the decisions didn't understand some of the decisions being made either. So again, That comes back to the SOCs mission statement. And if I go back on the slides, you'll see I actually even did it here to some point, and that I said that this talk is about a security monitoring program with a mission to detect and respond to threats. So it's important to actually have that. And also to have the leadership buy-in, because realistically, what's going to happen is if you don't have that, is you're going to get your SOC is going to get sent all of the shit security work because they're going to be the 24/7, 365 group with the high head count. So it's important to kind of keep that in mind and manage it.
So, quick question about that too. So,
Yep.
In our current situation, I'll speak for myself. So, our SOC team is before we just merged. So we had a smaller team, but we were security, so we were everything, right? Vulnerability management, yada yada, list.
Yep.
However, we've still retained a lot of the what I call security engineering tasks, which are related to the different our various platforms for alerting, EDR, whatever. Is that something you would also recommend, or would say that needs to be maybe segmented or be put on another group so to free up those SOC or those analyst style resources?
It depends on the size of the team. My personal opinion is I like for my SOC employees to manage the applications, but not the infrastructure. So that comes with writing the actual detection logic, managing like the actual policies, but not necessarily managing the Linux server that it may run on or the firewall itself. I think that there's depending on your tool set and the way that you're interacting with the tool set, I guess that's a big it depends. But one of the tricks that I actually have done whenever I was working for a singular organization was to just dedicate somebody to just, their primary job role and name and with the management team was security monitoring first. Even if they had engineering task, if, an alert came up or whatever it might be, that was to take priority over whatever happen. And that's a good way to kind of get started until you can start offloading some of that work more and more to the engineering teams, or at least the approach that I've taken.
No, that makes total sense. Yep.
You mentioned like leadership buy-in and mission statement. If you're just starting out wanting to build this, are there training programs, instructional manuals, field guides for boards of directors types of folks to know what to write into that mission statement, or do you just have to make it up and figure out on your own?
So I've I've only worked for one organization that had a mission statement, and that was Palo Alto ahead of time. So that's actually a good question. I'm not going to be able to tell you that one for sure. The way that I've done it is if they didn't have a mission statement, I essentially just kind of wrote one myself and said, this is what it is. Can I get buy-in? And if not, what do I need to change it to get buy-in? And just kind of force the issue.
Okay. Because ultimately it becomes a bottom-up. Here's, my, expertise and training or whatever to say this is what I think we need, but it's not a top-down or even from an industry perspective. There's no best practices like here's how to build a SOC 101, which is part of what you're talking about, obviously.
Yeah.
So it's going to be organization specific, but there's also certain key criteria you need to meet, kind of like what we were talking about during the news segment. There's certain like configurations and things that are like minimum standards and things that you need to, from an operational perspective, you need to set, but also from a monitoring and reporting perspective on your SOC side. Like how do you know which SIM, like your presentation a couple years ago, which SIM rules do you write and which ones do you not write? It's almost organic at that point.
Yeah, so that's actually cool because we're going to dig into that today.
Nice.
Yes. So we'll get into some of the SIM rules, and we'll actually touch on that pretty soon. So one of the things that I've noticed that all of the major and well-run SOCs have is automation is absolutely a first-class citizen. That can be anything from just having, again, whoever your SOC analyst or your security monitoring team, just having someone dedicated to just know Python, and while they're working alerts, identify just tedious tasks to automate. And then as you grow, I've actually seen full-blown dev teams dedicated to just the security teams within the SOC. And I'll actually show you some examples. One of the things I really wanted to do with this is to show some actual operational examples of some of these different things that are being done. So one of the things I would definitely recommend, though, is that you have, if you do have some sort of automation team, or even like an internal dev team already, one thing you can do is have them work alerts at maybe just 1 week a month, or 1 day a month, or whatever it might be, just so that they can understand that workflow and actually really understand what the real pain points are. And that can be a great way to get started at identifying and start building automation into some of your security, I guess, tool bag. Again,
Don't call me that.
I was with you. Now you've gone too far, David. Now you've gone too far. With the devs working alerts? What?
So, and then also one of the things that these SOCs do is automation is heavily used to reduce the number of false positives. I actually have helped companies build playbooks that have completely automated the response and investigation to certain tasks to the point where all the analysts had to do was open up the case and then say, yes, this is bad, no, this is not bad. And an example of that was actually around some phishing. And I'll actually show some high-level outlines on that. So let's dig into something that's actionable. So this isn't something that I gave a talk on here at ColaSEC in the past, doing detections as code or unit testing your detection logic. This is a great way, or a great example of how automation is actually a first-class citizen. And what I mean by that is your different security analysts and your different members of your security team would theoretically interact with a SCM platform, so like a Git or a GitLab, something like that. GitLab is totally open source and free. You can run it on-prem if you need to. They do unit testing on the actual detection logic itself. So again, this is actually a process that I helped implement at Soteria in a white paper that I wrote. So feel free to check it out if you want to go into the details, or even listen to the ColaSEC talk. But long story short, the idea is you codify your detection logic, storing it in JSON, YAML, and I'm talking the raw actual detection logic. And then as you make changes to it, as you write new detection logic, you also write tests to actually make sure that that detection logic triggers like you think it is. So some of the things that these organizations are doing are things like spinning up automated, just like cloud instances of a Windows server or whatever it might be, then kicking off a MITRE Caldera test or an Atomic Red Team test. Did they EDR or whatever their detection tool set is capture? If not, that test then fails and their detection engineer says, okay, I need to go back and tweak this. We would have just potentially had a false negative if that went to production. Some of the other things that it leads to is, and this is what we used to do whenever I was at Soteria, and is what we actually do now at Corvid Cyberdefense as well, is it also lets you essentially red team your detection logic. And let's actually look at this. So let's see here. Here is something we'll talk about in a second. Here we go. So this is a good example. Can you guys still see my screen? It should be like a YAML configuration. So I showed this in the actual detectors as code slide, and this is actually free detection logic, by the way. But essentially the idea is companies are going through, this is the actual detection logic here for the EDR that we used in this case, and we put that into a codified pre-standardized template so that we could add our own MITRE attack IDs. You could add references. So let's say you're using a SOAR platform, or maybe a case management tool like the Hive. Anytime you get that alert, you can also just drop the references to read about what that attack technique might be. Same with the description. That could be the Hive description if you're using that as a case management tool, whatever it might be. Again, use case, this would be installation/execution if you're looking at the kill chain. And then contributing source to behavioral based rules. So I'll actually give this detection logic out for you. The idea behind it is if you're looking for MSHTA as an executable, if you're not familiar with that, it's the Microsoft HTML application executable. And essentially what it used to be for was back in the day, if devs wanted to have a GUI to some Visual Basic or JavaScript or whatever it might be kind of code, that would be a way that they could execute it. So it's something that's really rarely used. You might see it more in ICS environments with some shitty printer drivers. But if you see it trying to communicate to a URL, so if you see MSHTA spawn with HTTP, HTTPS, or FTP in the command line argument, probably not going to be something that's safe. So good piece of detection logic right there. But this is a good example of how you could actually codify that detection logic. And again, I wrote this, or I co-authored this white paper with Brandon Poole, who's also presented at ColaSEC. And if you want to read more and really dive into that, the white paper is on their website, soteria.io/detectors as code. And feel free to ping me. I'm always happy to answer questions on it. So that's something that too made such a big difference. So for those of you that aren't aware, I'm currently a SOC manager for a managed services provider, and essentially had the same type of role at Soteria, which was also a managed services provider. So one of the things that was really important to me was reducing the amount of false positives, but being able to do that confidently and to be able to do it at scale. So if I have 200 clients, I don't have to go into all of their individual tenants and upload code and all that jazz every single time I make a change to something. And I needed to make sure that it was a repeatable and documented process. So this is one good example of how the automation is a first-class citizen in some of these modern SOCs. Another good example is doing threat hunting with Jupyter Notebooks. So you actually do not need any paid tools to do threat hunting with Jupyter Notebooks. In fact, most of the blogs and resources that you'll find out there are going to be using Elasticsearch or Graylog 2 and Python. It's a process, and it's just learning what data do I need to query, how do I want to manipulate that data with Python, and then what am I going to look for. So I've actually seen some companies use some Jupyter Notebooks and do their threat hunting with this, and they actually write their own ML algorithms on the fly to look at just things that you wouldn't expect or commonly expect a machine learning algorithm to be able to be run on. And because it's with their SIM data, they're able to really legitimately correlate it in a way that they understand, because it has all of their different security tools being fed to one place, and they understand that data to be able to manipulate it properly with Python, getting the output that they want. But let's show some good examples of this. So I'm a big fan of John Lambert, who I'm going to show some of his Jupyter Notebooks, but he has a great blog on the GitHubification of InfoSec. I'd definitely recommend reading. And it goes over how GitHub is really commonly used and some of the benefits it can really give you. But he also has some examples of his Jupyter Notebooks. So with Jupyter Notebooks, if you're not familiar with how they work, essentially the idea about it is you have a notebook or an interface. And let me actually see if I have VS Code. I don't have it installed. Essentially, you would just type in your Python code in VS Code. You'd hit enter, it execute it, and then it outputs it out. But you can see it in an interactive manner. So let's look at some of these notebooks. Malware decode demo. And what I like about them too is because they are notebooks that you can output the data from, is they're shareable. So if you come up with a great notebook or a great hunt, you can share them out with other people and other teams to be able to say, hey, this is working awesome for me. And then they can develop a repeatable process around that. And also you can just pop it into your SCM instance, so like GitHub, and now you have it stored. So if you need to go back and prove to auditors what you did, you can show the exact code that you executed and the exact output, how you came to whatever conclusions, and have full version control, everything that you have built in to get change control, whatever you might need. So cool. So that's another good example. And then Playbooks. I hinted on this to some degree. So my last job role was, again, a SOAR architect, working on a tool. Let me actually make this bigger so it's easier to see the screenshot. Working on a tool called Demisto, or XOR is what they renamed it to. And the whole idea of that is essentially they have some pre-written out-of-the-box automations, and you can drag and drop those automations to automate different parts of your investigation. So for example, I might have a phishing playbook. I'll have a step that would automate and process the email, pull out all of the indicators, send an acknowledgement that it was received to the end user that said, this looks suspicious. Can an image of the email be rendered? And if so, it'll render an HTML image that is then presented to the analyst by the time they open the ticket, so they know what the email looks like from an HTML perspective. Again, extract the indicators, automatically go out and take a screenshot of all of the URL in question. I mean, like, look up and do reputational checks, that kind of thing. Really, whenever I was developing SOAR playbooks, people would ask if you could do X, Y, Z with it. With the SOAR platform, you can do everything. It's just a matter of if you should or not. But one thing that I want to say is automation is a process, not a technology. You don't buy a SOAR platform and now you're just doing, automated stuff. You should have a use case and start building out some of those automation processes so that you can figure out what some of your pain points are when you're doing your automation, so that you can develop the use cases you need to identify which SOAR is going to really best fit your needs. So again, focus on building the automation process internally. And then as you kind of identify the need for a SOAR type platform, then go spend the buku bucks on one.
So is there, and there probably isn't an answer to this that is universal, but is there a ballpark number for if I'm planning to invest in a SOAR platform and I've got X number of hours allocated presently to the operation of a detection and response team, is there a number of or percentage of hours I should count on allocating to just developing automation work?
It depends. So I would say
Right.
42.
Yes and no. Yes, in the fact that you're probably going to want to always continuously be automating, but once you have your core set of kind of playbooks identified, so like your malware playbook, your phishing playbook, that kind of thing, it really becomes adding automations as you identify new use cases to automate, and then updating them as APIs change. So I hope that maybe answers your question to some degree. So after you get that initial setup, it's mostly just maintenance and adding it as needed. And then again, I always wanted to play with the detection capabilities of SOAR platforms, but weirdly enough, I had trouble getting buy-in on doing that. But yeah.
So, and I was asking kind of a guiding question there. My experience in automating things is that there isn't a point at which you scale back and spend less time on the automation work. You dive in headlong and you automate. There's a initial heavy lift to get it started, but then once you start automating, it's sort of a drug you can never get off of, because well, there's a whiz bang thing that does this, there's a whiz bang thing that does that, and well, what if we did this? And there's sort of the things you want never ends. So
Yep.
I assumed that was the deep hole that I was looking at. I just wanted to make sure.
Yeah, and well, so that's actually one of the good use cases for a SOAR platform, is just that the maintenance of different automations can become pretty beastly, and having a SOAR platform essentially is offloading that to some degree. You're now paying a company to manage the API integrations and some of the automations, and you're also benefiting with the fact that the more kind of companies and more customers that they have, the more automations that they have in support. And seriously, if you can stick around for the end, I will seriously show you a really great life hack on saving a ton of time automating IT stuff.
Hopefully our Google Meet doesn't expire.
We'll hop back on another one if so.
There you
David,
go.
put another quarter in it.
Okay. Hang on.
Cool. So, and then part 3, and it looks like we're going to have actually a lot of time to dig into this automation stuff, which will be good. Let me make sure I hit all of my automation piece. Oh, yeah, this was more, again, so one thing that I didn't hit on is the detections as code stuff. I brought this one up specifically because it's something that whenever I was writing the white paper here originally, we had a few people actually do a read of it and just give their opinions to us to see, what they thought of the process, to see if, they were doing it, that kind of thing. And I wasn't aware that other people had really even come up with this idea, but it turns out, a lot of these bigger security organizations have been doing this for a long time. And it's just one of those things that's not really talked about. And I actually just recently came across this blog post by Dr. Anton Shuvakin from Google Security, formerly of Gartner. So it's something that's being done, and again, it's a perfect example of the slide I kind of showed at the beginning. It's not something that's widely talked about, so I wanted to really kind of bring that to light because it does make such a big difference on false positives. Okay, so let's go back here. So understanding of detection engineering. I actually, on one of my second interview ever, one of the questions that I had was from the SOC manager, and he asked if I knew how to create SIM detections or how to write SIM rules. And at the time, I didn't. And I told him that, and he was like, "Me either. I was just trying to see if you knew." Because that's a skill set that we're looking for.
Nice. Well played.
So it's something that I've seen that a lot of the modern and big name cybersecurity companies are doing, and that's being done in a lot of the really big name companies like the Microsofts and the Googles, basically a lot of these big Fortune 500 companies. And a lot of people have not even heard the terminology or even know that this is a job role or position. But essentially, something to really keep in mind is detection engineering is a process, meaning it's going to be constantly evolving and you're going to be constantly updating and writing detection logic. And it's going to be something that'll give you much higher fidelity alerts than your out-of-the-box detectors. If you're relying on third-party threat feeds or data feeds and out-of-the-box detection logic, you're probably going to be missing stuff. And that's just because of the fact is they don't know your environment well enough to A, push out something that's going to be tuned well, or B, they don't know your environment well enough for the specific applications that you may use to know what normal looks like to be able to have a rule. So basically, essentially having some sort of detection engineering program is important. And what you can do when you're starting off is assign someone a role. And I know this might sound silly, but it's a little social engineering to some degree. If you have the capability, even give someone that as their job title. Or if you're actually hiring for a position like that, make sure you have that as your job title because you'll attract a more modern minded person that's aware of that type of role. But if you can give them that as a job title, it kind of subconsciously gets them thinking in that line of work. So how do I build detections? How do I tune this properly? How do I kind of manage and prioritize my detections? And how do I get off of just alerting on IP addresses and hashes and stuff like that and get on to being more proactive rather than having a reactive security program? And what you'll see is if you go back to this slide, we essentially really did just lay out a real detection engineering process just in this white paper. So again, like this is what we really did. We would submit Git issues that would get be an issue in our SCM platform, which was GitLab. We had it in that YAML detection logic, like I showed just a minute ago. We would, anytime we would make a change or deploy new detections, it would be automatically checked out. We would execute some tests against it, and if it passed, whatever, it would get deployed to production. If failed, it would go back to the analyst. So
But
this is a great. Go ahead.
sorry, but detection sounds like reactive to me, but you're calling it proactive. Am I confused here?
No, you're not actually. I actually really like the word detector more. I am very bad about using detector versus detection. I call them detectors, and I'm going to show you some examples of behavioral detectors here in a second.
Okay.
So a good way to get off of those IOCs. So let me see what the next slide is. Okay, perfect. So ways to get started. The Pyramid of Pain blog is one of the best blogs to get started on this. It was written by a SANS course instructor, David Bianco, and it covers the concept of the Pyramid of Pain, meaning if you have, and if you're alerting on hashes, that's super simple for a bad guy to change. You just add some padding. Honestly, like it's almost just going to be the case for most of the stuff that you see. It's going to have a different hash for each environment. Not always, but it's going to be very common. Again, IP address is super easy to change now with the cloud being so prominent. I think they're one of the most garbage indicators because you might get a hidden IP address that hosts 1,000 different sites, only one of which is malicious, and you have no context on anything other than, hey, this is bad.
Oh God, AWS is malicious.
Yep. And then you get to things like domain names. Again, you can still automate the changing and creation of those with the domain generation algorithms. But you start running into things like cost. You have to have that knowledge to be able to do that. Network artifacts, again, then you're starting to get into changes in the tools and the skill set. So you might have something to the tune of like a certain URI or certain user agent that's used in your C2 beacon. If you're not the writer of that tool, you may not have the ability to go through and change that user agent or that knowledge. So it becomes harder and harder to evade the higher and higher you go up into that. And if you can start alerting on the actual detections, or sorry, the tactics, techniques, and procedures of the behaviors, you can become a more proactive security program. So rather than saying, okay, I have these malicious hashes, these are the maybe emotet maldoc hashes, alert on the actual emotet behavior of, it's going to be some sort of maldoc. So maybe it's Microsoft Office, maybe it's Microsoft Excel, spawning PowerShell. So I'm going to create an alert that anything that spawns PowerShell as a maldoc is going to send an alert to my SOC. And now any malware that abuses the behavior of using PowerShell to execute code from Microsoft Office, well, you've just caught it, whether it's Emotet, TrickBot, or any future malware to be written. So it turns your SOC into proactive SOC, and it also makes it a lot more difficult for adversaries to evade your defenses. So it becomes like, okay, well, now I've just taken maldocs out of the equation to get past your defenses. Now I have to kind of retool, come up with a new idea of how to get into that target network.
Or they're going to move on to the next guy.
Exactly. That's actually what I was just about to say. So at Soteria, all of my old colleagues, or most of them, were former NSA tailored access operations. And I can tell you for a fact that they have budgets. Bad guys have budgets too. And especially financially motivated actors. They're not going to spend a ton of time targeting an organization whenever there's thousands of other organizations that they could just send their spam mail to and compromise without spending all this, this effort. So really great blog to read. Again, if you just type in Pyramid of Pain, a ton of different other sites have actually written different blog posts based off of this concept. So it's a really great blog post to give a read. Second is understanding the MITRE ATT&CK framework, and we'll actually show you how to make use of this. So one thing to kind of remember is the MITRE's ATT&CK framework is just that. It's a framework and it's a guide. It's not something that is a Bible. So it's meant to be flexible. It's not going to be all encompassing that has every single technique. There's going to be stuff that's missing on there. And even the biggest organizations are not going to have 100% coverage. It's just not possible, and you shouldn't expect as much. And then, of course, utilizing industry threat reports. So Red Canary actually puts out my personal favorite report, and it's their threat detection reports. And we'll look at that in just a section, or in just a second. And the reason that I love it so much is because it goes over specific MITRE ATT&CK techniques used, how they're abused. It tells you detection opportunities, shows you actual examples. It's just an awesome report, tells you the popularity, so on and so forth. And then we'll also talk about I love the attack framework. So I'm almost not sure if I should just wait to say this, but for me, if you didn't know, the attack framework initially really focused on the phases 3 through, I want to say 7 of the kill chain, basically the delivery through the action on objectives, and it just went really in depth on those and provided actual examples and got a lot more granular with them, and it really cemented how to think of an attack. So if I see something like I don't know, like a run DLL 32 type behavior, I might also see, or like I'll know that that's potentially some sort of defense evasion or technique or a way to execute code maliciously to get around like application whitelisting. And that's something that I might not have been able to know before unless I had just spent all of my time reading blogs and doing forensics and stuff. Whereas the MITRE attack framework just show it to you.
It's got a lot of great information. And I guess as we're getting that together, what would be your best thought on how to get the log data that would provide you with the ability to do these detections?
So interesting. So that's actually one of the reasons. So let me go back here. In the detectors as code syntax, that's actually part of the reason that we actually did it. We actually added the attack IDs ourselves to our own metadata so we could track that type of data because it wasn't in our security tooling. More security tools are starting to include it in their logs, but sometimes you just got to get crafty. If you're using a case management system, one that's really common is like a tool called the Hive. What you can do with that is essentially write your detections. So essentially, if you're doing your detections using a tool like, let's just say, for example, you're using Graylog or ElastAlert in Elastic, you're doing your detections in Elastic and then forwarding them to Hive, and then you can do things like set individual rules with their descriptions and then assign tags that'll have those MITRE attack technique IDs, and then you can build TopX dashboards in your case management system based off the tags, that kind of thing.
Okay, so you're basically at that point where you're doing it your ingest time or your detect time within that, as opposed to maybe a different level.
Correct. And that's really going to be dependent on how you're pulling in your alerts. The way that a lot of organizations are doing it with SOAR platforms is they use their SOAR platform to pull the alerts directly into the SOAR. They still go into the SIM, but that's where they pull the initial alerts. And then that way they can go through and do some automations and stuff before it ever hits an analyst. And a lot of times there's an out-of-the-box MITRE attack integration with XSOAR. So there's I guess different steps in a pipeline where that might occur.
Okay.
Yeah, and a good example, I think some organizations will stand up something like a Kafka server in front of their SIM deployment, and then do some data enrichment and in that Kafka server, and then from there forward that enriched data to their in SIM. So,
Excellent. Well, I believe other David has gotten us back up and ready to go. So thank you for the quick pause, and apologize for that.
Yep, no worries. And
Yep.
let's see. So I kind of hit on everything here. Let's look at how you would actually make one of these. So if you go to the MITRE attack Navigator GitHub, you can just do an attack Navigator. If you just search that in Google, it'll be the first thing that comes up. But there's a few concepts for it. So there's the concept of tags or layers is what these are. There's, of course, the techniques. Then there's sub-techniques. So active scanning is technique T1595, and then these are T1595.001, so on. And then you have different kind of tools for it. So let's go ahead and start one from scratch. This will only take a minute. This is just an attack 101. or Attack Navigator 101. But what you'd want to do, create a new layer. Enterprise is going to be the most common thing that you're going to choose. You'll have identified your attack groups ahead of time. You can go through here, just select them from the dropdown. It's that easy. So we'll just choose APT 11 for this group. And then one other thing that you'll want to do is go to scoring and add a 1. So what this will do is it'll give each of these a weight of 1, so that when we combine layers, we can start doing a heat map. And we can, of course, adjust the scores up. So like, let's say maybe a specific APT group we know is actively attacking us. Maybe we give them a higher score. And then, of course, what we'll want to do is a color setup. To me, it does it backwards by default. It starts off red and goes to green with the more hits that it gets, whereas I like going from green to red. So again, we'll just call this C layer. Then we'll create a new layer. Again, enterprise. Just do something real quick. Oops, let me undo that. Let's see, here we go. Okay, and then now what you'd want to do to combine these is if you do create layer from other layers, you just select the Enterprise Attack Navigator. I just typically leave all of these others blank, but then it has what's known as an expression. And you'll see these little yellow keys up here. So there's A, B, C, D, E, and so on. So what I'd want to do if I wanted to make a tab for just the C and D is I would do C plus D and then create custom navigator. And now I've created a heat map. And I can see specifically what are the more common techniques that the APTs that might be potentially targeting my industry are. So I could see things like, let's see, process injection. And then here are some of the attack techniques that they're going to be using from within that sub-technique. So then I can go through and test to make sure that I have visibility into these techniques and can detect on them. So that's the kind of real quick 101 that I'll do on Navigator. Anybody have any questions on that by any off chance?
Are these weighted as far as like current, today there's this threat, tomorrow's this other threat?
So it's totally on you. You set the weight whenever you're creating the layer. When you click this scoring tab, you could set it 1 to 100. And then if you go to the color setup pane, you can set the low value, which would be, of course, the green or the top, is 0 being, that'll be the low, 5 being high. And then the closer it gets to 5, the darker red that it'll become.
Okay, so you can kind of play with it and figure out how do you,
Yeah,
because the prioritization is really difficult, obviously.
Yeah, I'll actually talk about that some too in some of the approaches that I've taken.
Okay.
On that front. Okay, so were there any other questions on the Attack Navigator front? Okay, I'm going to assume no. I'm going to kind of go through the next sections just a little quickly because I want to hit on that automation piece. I think that'll be really fun for a lot of people. And then lastly, the thing that I wanted to show is, again, the Sigma project. It's created by a guy named Florian Roth, who just does awesome detection work. But this is an example, and if you notice, again, this is just codified detection logic. In this case, it's a YAML, and you have just essentially some metadata about it and whatever. But you can take that and then convert it to like a QRadar query, and now you have QRadar detection logic for whatever that attack might be. So let's actually look at some of that. Here we go. So this is the GitHub repo for it. So you can go to rules. Windows is going to have some good ones. I actually contributed some of these when Mouseye, darkware, and then you can see an actual rule. This is a great place to get started for detection engineering. So if you're looking at trying to figure out what kind of detection logic to write, or even like what a good examples look like, this is a great place to do it. And it's all totally free. This is something that I will also actually use sometimes whenever I'm investigating something. I'll might pop in a command line argument, whatever it might be, and just search this repo and see if I can find some detection pieces on it, so I can get some other kind of context around it if I've ever see something and I'm not really sure what's going on. And then there's also this tool at uncoderio, where it takes a lot of the known detection logic and then converts it to some of the built-in backend. So if you're using, I don't know, Graylog, ElastAlert, Carbon Black, whatever it might be, QRadar, I think, is the one that I showed in my example. It'll translate that into its associated rule that you would need. And you may have to play with the fields, but at the end of the day, the logic is there.
Nice.
So
that
this
way
is
you're not stuck in the proprietary code.
Yeah, exactly. And the great thing about it is it's because it's an open project and it's maintained, anyone can contribute false positive information to it. So you can open up issues and just add even just a false positive, like, hey, I also noticed this is a false positive because XYZ. Now, they might ask you to prove it to be sure before they push it out to their production if they can't validate it themselves. But because of that, it leads to these being well maintained and typically fairly high fidelity.
I was going to say, it smells like a vulnerability.
Yep. And then lastly, this guy's Twitter account is the best thing that's ever happened. So his name's Samir Busadi, and he works at Elasticsecurity, and his entire Twitter feed is a great example of what a detection engineer might do all day. So it's essentially launching attacks, looking at the event logs, and figuring out individual artifacts. And he just posts all this for free. So this is a great way both to learn just weird, random, life hacky type stuff about some of these, more rare processes or command line arguments, and just honestly, it's just a great way to get detection logic. His whole Twitter feed is just absolute gold. He tells you why, highlights the things that are important. I mean, it's great. And then, so let's talk about prioritization. How do you come up with the prioritization? So I approach this 3 ways. The way that I've always done it is you have your internal threat intelligence. So what are you seeing in your own environment, and from your incident response engagements, you should be doing your lessons learned, and then funneling back the evidence to your quote unquote detection engineering team to say, hey, how could we have detected this earlier in the pipeline to create new detection logic? That should be something that's a cycle. So every incident, you should be working to try and detect that higher in the detection life cycle. So that's one part of it. So you want to base part of it off your own internal intelligence. The second part is just getting an idea of what's going on in the industry. So a real great report is the Red Canary Threat Detection Report. So this is what they release every year, and it essentially rates the most abused techniques across all of their clients. It focuses on the endpoint because that's what they're limited to, but it is just absolute gold. So if you click some of these techniques, it tells you how many confirmed threats that they saw for it. It'll go into why they use it. It breaks down to encoding. All of these are flags to execute a base64 encoded command with PowerShell, and they actually have broken down the most commonly abused ones by the bad guys. And then it actually will show you some of the new tradecraft that they're starting to see to get around detection logic. And then they have things like how you could weed out false positives when you're creating the detection logic, and even straight down to detection opportunities and collection requirements. One thing that you'll see, and that's really common in this report, is when you're looking at these collection requirements, you'll notice a commonality. Now, granted, there is some collection bias since Red Canary is limited to endpoint collection tools, but in the MITRE ATT&CK framework, process and command line monitoring will give you the single most visibility across the MITRE ATT&CK framework. So from an importance perspective, having good process monitoring and command line argument monitoring is going to be extremely important. And you'll see that across all of these. But again, they give you things like detection requirements, examples, how to weed out false positives, yada, yada. And then, so that's kind of a good way to get started. So reading the industry threat reports, I like the Red Canary one FireEye, CrowdStrike, all of the real big name security vendors typically put out something similar. FireEye does like an M-Trends report. Verizon does a DBIR. Looking across all those reports, seeing what the industry is seeing is common, that's also going to play a role in prioritization. So I would say another 30% or 33%. And then lastly, using your own hunches and research. So this is a lot more difficult for teams that don't have a dedicated detection engineer. So if you're a smaller team and you're just getting your detection program started, you might not have the manpower or the resources to really come up and do your own kind of research on attacks just all day long, unless you're doing it at home for fun, which, don't do that unless you're getting paid the buku bucks. So it can be difficult to do that. So if you are limited in that case, it's really prioritizing it based on what you're seeing and what the industry's seeing, and then kind of weighing that against also, what are your adversaries abusing and what are the most common techniques that they're abusing and that they're known to abuse. Does that help in terms of prioritization? So for example, let's see.
Yeah, for us, it seems more organic, because otherwise it's hard unless you pay for a service that tells you like, hey, you're being attacked. Then you're gonna just either prioritize based on criticality, like CVE kind of a criticality, or organically, like your environment, and you're gonna prioritize that way.
Yeah, there's a lot of things. Like if you go down this threat detection report, if you're really not sure where to start and you're just trying to get something out that's going to get you the most bang for your buck, taking some of these things like the threat detection report and getting some of these high fidelity, really high quality alerts that are commonly abused is a good start. And then from there, just really going through and prioritizing it based on, your own kind of threat modeling and what's important to you and your organization.
So basically, the Reddit test.
Yep. So at this point, if there's no questions, I want to show you guys the super ultra secret programming tip.
Dude, that's the only reason I'm still on.
Okay, awesome. Let's go ahead and stop recording, and if you guys could let me know when that's done.
Yeah, let me switch this over here. Stop recording.
David, is it okay if this is on Twitch, or